Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're looking at 5 ways to think about multiplication. Not one way, not 2 ways, but 5 ways. The first way we're going to think about multiplication is multiplication as grouping. Let's try it out. Look at the dots I'm setting out here. What do you see? Now I have a number of dots set out already. Do you already see them in groups? How many groups do you see, and how many are in each group? Well, I see 1 group of 4, 2 groups of 4, 3 groups of 4. Now if we're thinking about grouping in terms of multiplication, we can say we have a number of groups, and each group has the same number of elements or things inside. And I can write a number sentence like this. I can say that there are 3 groups of 4. 3 groups with 4 inside each of them. How many dots do I have altogether? Well, I can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I can count by 4s, right? 4, 8, 12. That is multiplication by grouping. What if I do this instead? What if I set out the dots again? What do you see this time? Do you see the same groups? Now what if I asked you to think about the groups differently this time? Instead of 3 groups of 4, can you make other groupings? Well, I'm going to try it this way. Let's see, I can make a group here, and I can make a group here. So what do I have now? This time I have 2 groups, and in each group I have 1, 2, 3, 4, 5, 6. So I have 2 groups of 6. How many dots altogether this time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I have 6 and 6 more. And that gives me 12. So both ways help us think about multiplication as grouping. So here's the second way of thinking about multiplication. And this way of thinking about multiplication is through repeated addition. This one may be the one that's most familiar to you. And it is exactly what it says. This is adding something again and again and again. So say you have a pocket full of nickels, all right? 5 cents, 5 cents, 5 cents, 5 cents, 5 cents, 5 cents. It's a lot of nickels. We can think about it this way, can't we? We can think about it as 5 plus 5 plus 5 plus 5 plus 5 plus 5. All right. How many 5s do we have here? 1, 2, 3, 4, 5, 6. So we have 6 5s, so we can say we have 6 5 times. Or we have 5 6 times. Okay? 5s, we have nickels, 6 of them, right? But how much is this all together? Let's think about this together. We can count it, we can add them all together, or we can count by 5s, can't we? 5, 10, 15, 20, 25, 30. So this is repeated addition. I counted the same number again and again and again, and I added it each time, adding on. So 6 times 5 gives us 30. So that's the second way of thinking about multiplication, which is repeated addition. A third way of thinking about multiplication is through area. So I'm going to make a shape here. And I want you to look at its size, right? Now, if I make this shape, this rectangle, and I wanted to know how much space was on the inside, what would I count? Well, I can count the squares. And that's how we usually think about area, is in terms of squares. But let's see how much the sides are first. On this side I have 1, 2, 3, 4 measures. So this is 4. Across the top here I have 1, 2, 3, 4, 5, 6 measures. All right? So if I'm thinking about multiplication in terms of area, I could say this is 4 by 6. So this is 4 by 6. All right? Now, what does that mean, though? What is the area inside? Well, let's work that out. Let's see. I'm going to find out how many squares there are by breaking this big rectangle into smaller ones, and finally finding all the squares. So right now I found out that I have 1, 2, 3, 4 rows. Now I'm going to make columns. Let's go ahead and make columns here. So 1, 2, 3, 4, 5, 6 columns. So now I get back to my idea of 4 by 6. 4 rows by 6 columns. And now I should be able to count the number of squares on the inside. 1, 2, 3, 4, 5, 6. Seven, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 altogether. Okay, so I can say that a 4 by 6 rectangle gives us 24 squares in area. Now I'm going to do this backwards. Let's look at it a little differently this time. What if instead I gave you a shape like this? Okay. What is its measure? Well, if we count over here, we have 2 measures here. If we count across the top, we have 1, 2, 3, 4, 5, 6. 6 measures across the top. So I can say that a 2 by 6 rectangle gives us 6 and 6 more squares. So 2 by 6, or 2 times 6, gives us 12 squares, or 2 times 6 equals 12. So this is the idea of multiplication as area. Now, let's look at another way, the fourth way. And the fourth way of thinking about multiplication is multiplication as an array. So I'm sure you like the idea of an ice cream shop or visiting an ice cream shop. Now, in an ice cream shop, you have choices, right? So in an ice cream shop, you might be able to choose different flavors. And let's say you get to have these choices for flavors. Let's say chocolate, vanilla, strawberry, and let's say mint chip. Do those sound like good flavors? Now, it's great to have all these flavors, but also you might have choices about how they are served. So some people like to have their ice cream in a cone. Some people like to have their ice cream in a cup. And maybe a few people would like to have their ice cream on top of a cookie. So there's lots of different choices for ice cream and then different ways for it to be served. Now, let's look at this. These are all the ways in which you could have your chocolate ice cream. You could have your chocolate ice cream on a cone, on a cup, or on a cookie. These are all the ways in which you might have your vanilla ice cream. Your vanilla ice cream might be on a cone, a cup, or a cookie, right? Your strawberry ice cream you might find on a cone, a cup, or a cookie, right? And then your mint chip could be on a cone, a cup, or a cookie. Let's see what this looks like. We could look the other way as well. So your cone, you could have a cone that has chocolate in it, vanilla in it, strawberry, or mint chip. That's another way to think about it. Your cup could have ice. Your cup could be filled with chocolate, vanilla, strawberry, or mint chip. And your cookie could have chocolate in it, vanilla in it, strawberry, or mint chip. Those are all the different choices. So let's look at what we have right now. If we look at it, we can see that chocolate in a cone is one choice, vanilla in a cone is another, strawberry in a cone is a third, and mint chip in a cone is a fourth. Okay. If we look at a cup, we could have chocolate in it. Chocolate in a cup is one choice, vanilla in a cup is a second, strawberry in a cup is a third, and mint chip in a cup is a fourth. Are you seeing a pattern now? Let's look at the last one. You could have a cookie that has chocolate on it, a cookie with vanilla on it, cookie with strawberry on it, or a cookie with mint chip. So when I'm looking at an array, I'm looking at all the choices. 4 choices and 3 ways to serve. So 4 choices and 3 ways to serve. So I can write that down. So I have 4 choices and 3 ways to serve. 4 choices, chocolate, vanilla, strawberry, mint chip. 3 ways to serve, cone, cup, cookie. And this should tell me all the different combinations there are. And how many were there altogether? Oh, we had 4, 4 more, and 4 more. And I count 12 altogether. So there are 12 choices. And that is how an array works. The last one is very interesting. So let's do one more way to think about multiplication. Another way to think about multiplication is scaling. And scaling is about things getting bigger and getting smaller. So let's say we had a person, okay? And this person was, say, this tall. All right? And we'll say this person in this picture is actually 5 feet tall, okay? But what if another person came along that was twice as tall as this person? Be a giant person, right? Let's scale this, okay? So this person twice as big, this would be 1 times as big, but now we need to go all the way up here to go twice as big. Okay, let's draw this person. So this person is twice as big, right? This person was only 1 times as big as itself. Now, if this person here is just 5 feet tall, how tall is this person? Well, it would have to be 5 feet doubled, right? So 5 feet times 2. And how much is that altogether? Well, this particular person would have to be 10 feet tall. That's taller than anybody has ever been. Let's try another one. If we take a normal person who's 5 feet tall, and what if we want to make this person 3 times as tall? So let's see, 1 times as tall, 2 times as tall, 3 times as tall. Okay, let's draw the person. Has really long arms and really long legs, right? This person is 3 times as tall. as the first person. If this person was 5 feet tall, how tall would this person be now? Well, they'd have to be 5 feet times 3 tall. And how much is that altogether? Well, that's 5 and 5 and 5 more. This person will have to be 15 feet tall. Let's keep going. What if an even bigger person comes along? And this person is 1, 2, 3, 4 times as tall as the original person. And give them a bigger head. This person is so giant. All right, we know this person has to be 4 times taller than our first person. All right, if our first person was 5 feet tall, this person has to be 5 feet times 4 tall. And how much is that? 5 and 5 and 5 and 5 give us 20 feet. How about one more? What about if the last and most giant person came along, and this person was 1 times as tall as the first person, 2 times as tall, 3 times as tall, 4 times as tall, 5 times as tall as the original person? Okay, there's the head, there's some arms, and then some very long legs, right? This person has to be 5 times as much as the first person. The first person was 5 feet tall. So this person has to be 5 feet by 5 times tall. And how much is that? Well, that's 5 and 5 is 10, and 5 is 15. Another 5 is 20, and one last 5 is 25. We can look at it this way too. This person is going to be 5 feet, another 5, a third 5, a fourth 5, and a fifth 5. And we can count them. 5, 10, 15, 20, 25 feet tall. That is so tall. We can see with scaling how everything is about growing taller and taller and taller. So we start with our first person, and it just grows and grows and grows and grows until we get to the tallest person. Okay? So scaling is about things growing. But we can also think about scaling as things getting smaller. So let's look here. Look at our next giant person, 5 feet times 4, right? If we want to think about multiplication going backwards, how tall is a person that's half as big as this person? Well, if this is a person who's 5 feet times 4, we need a person who's half as tall. Which person is that? Well, we could say half of 20, or we could also say half of 4. So instead of 5 feet times 4, we could take half of 4, right? 5 feet times 2. And that takes us to here. So this person's only half as tall as this person. And that is scaling going the other direction. So, let's look at something together now. I've talked about 5 ways to think about multiplication. The first way was about grouping. And this way was about organizing objects so you could see them in patterns of groups. Now sometimes you may have a set of things that you think make one particular kind of group, but then again they could make another kind of group. So the most important thing though is that all the groups must have the same number of elements or things inside it. These have to have 4 in each one to make it multiplication, right? 3 times 4. Every one of them has to have 4. This one says 2 times 6. Each group must have the same number, so they have to each have 6 in it. Okay? And that's multiplication as grouping. Let's look at the next one. And as I said, this one's probably one you've seen quite a lot. This one is multiplication as repeated addition. And in repeated addition, it's about adding a same number again and again and again. So in this case, we worked with nickels. And we said we have a bunch of nickels, and we add them together, and we can think about them as repeated addition. Again, in terms of multiplication, it works as long as all the numbers have the same value. What about our next one? What about multiplication as area? In multiplication as area, we think about rectangles and the space inside counted in squares. So we may have, say, a rug that's 4 feet by 6 feet, and we can say to ourselves, how many square feet can we get into each of these? This is 1 square foot, 2 square feet, 3 square feet, and you can count how many squares can fit inside the larger rectangle, and this is multiplication as area. The next one, multiplication as array, is about choices and all the different ways choices might be given to us. So if we look at this, we can see having 4 different choices compared to 3 different choices gives us 12 choices altogether. And this is another way of thinking about multiplication. The last special way of thinking about multiplication is scaling. And scaling is about things growing from 1 times something size to 2 times, 3 times, 4 times, 5 times, and more, you can imagine, or shrinking. And scaling goes 2 different ways. So these are the 5 big ideas about multiplication. First is grouping, then repeated addition, then area, array, and scaling. I do hope this has been helpful to you.